Good evening. Welcome to the fifth week of problem solving session for this course, Availability and Management of Groundwater Resources. We'll be discussing questions related to the lectures taken during the fifth week that involves porosity, permeability, transmissivity, and storage coefficient. Your assignments, the fifth week's assignment is due tomorrow, and the next week's assignment will be due by September 4th. Before we start the session, we'll wait for a couple of minutes for more participants to join. Okay, so we'll get started. Like every week, those who are new, I'll be showing a set of questions through the PowerPoint presentation. You will have to put in, and it'll be multiple choice questions, and you will have to put in your answers in the chat box, after which I'll be discussing the solutions. So we'll start with the first question. What is the relation between transmissibility and permeability for an aquifer of depth D? We had discussed the concepts of transmissibility and permeability in the previous classes. So these are the four options. You'll have to put in your answers in the chat box, and after that we'll discuss the right answer. So Arif and Chakravarti can put in your answers. Okay, so let's discuss the answer. The correct answer for this question would be B. Transmissibility, as we discussed, is a property of the coefficient of permeability or hydraulic conductivity and the thickness of the aquifer. Now, coefficient of permeability or permeability is nothing but that property of the material that is allowing water to easily pass through it, to easily transmit through it. And say if it is a material like gravel or sand, there are a lot of pore spaces. Water can easily go through this gravel material. Similarly, if similarly, on the contrary, if it is a stiff material like clay, even if you pour water over clay, the time taken by water to seep in through clay particles and move downwards will be much higher than the rate at which it will flow through gravel or sandy soil. So this is because sandy soil is more permeable and clayey soil is less permeable, or it is to the extent of it is considered as more as an impermeable material. Similarly, even if you pour water over rocks, it is not going to go through the rocks. It is going to go over the rocks. That is because rock is an impermeable material. Now, transmissivity or transmissibility, these terms are interchangeably used, is the product of the hydraulic conductivity and thickness of the aquifer. So, transmissibility is basically the capacity of a porous media. When you're representing a porous media and when you're taking out a small portion of the porous media, say there is 5 meter cubes of porous media, that portion which is responsible, when you consider a porous media and when you're considering a small portion of the porous media, what is the amount or capacity of that portion of the porous media to transmit water is depicted by transmissivity. So here, the main parameters that come into play are the hydraulic conductivity and thickness of the aquifer. And if you notice, you can also see that transmissivity uh, comes in the dimension L square by T, which means that L is the dimension associated with the length of a material and T is the dimension associated with time. So it will be in the unit of centimeter square per second or meter square per second or centimeter square per hour or centimeter square per day or meter square per day, whatever it is. The dimension is L square by T because K, the unit of hydraulic conductivity, this is capital K, not small k. Capital K is the unit of velocity, meter per second or centimeter per second or meter per day or meter per hour. It is the unit corresponding to that of the velocity. That multiplied by the thickness of the aquifer will give a unit corresponding to this dimension. So this is a very important term, particularly in this week's lecture that is considered. Transmissivity is a very important property that is being discussed. It is the capacity represented by a small portion of the porous media. The capacity of it to transmit water is what is defined as transmissivity, and it is mathematically expressed as the product of the hydraulic conductivity and the aquifer thickness. So clearly the units of transmittivity are in terms of L square by T, which like I earlier said. Now here they have given a example where hydraulic conductivity of an aquifer is 100 meter per day and the thickness is 10 meter. So 100 into 10, it will be 1000 meter square per day. Similarly, for another aquifer whose hydraulic conductivity is only 50, but the thickness is 300 meter, it will be 15,000 meter square per day. So this case has got a higher transmissibility or transmissivity compared to the first case. So although the hydraulic conductivity is very high, we had learned what is hydraulic conductivity or permeability. Permeability is the ease with which water is transported through the medium. But although the hydraulic conductivity is higher than the one in the case 2, we see that the transmissivity is higher in the second case. It is because the portion or the thickness that is taken, thickness of the entire porous media that is taken into consideration is much more than the one that is taken into consideration in the first case. So this is how we gain inference from this property of aquifer material transmissivity. So the correct answer for the earlier question would be a product of the hydraulic conductivity into thickness. You have to be very careful of the terms. Transmissibility is represented by T, permeability is represented by K, and depth or the thickness is represented by D. So T is equal to K into D. This option might be a bit confusing. So be careful of when you go through the options. Moving on to the second question. The coefficient of permeability indicates the ease with which water can flow through a soil mass. That is basically what a coefficient of permeability or the property permeability is all about. Now, the soil type out of all these four, which has the least probability permeability, is which one out of these four options? Is it gravelly, clayey, sandy, or both sandy and gravel soil? The one with least permeability. Pretty simple one, something we have discussed earlier. Chakravarti can also put in your answer in the chat box. You can either personally put it or you can put it commonly for everybody in the chat box. Okay, so I don't see any more answers coming, so we'll move on. So, like I said, it is the ease with which water can move through a particular type of soil. So, gravelly soil, we know that water flows quite easily. Sandy soil also. Clay soil is one which through which water flow is really difficult because it is nearly an impermeable material, and it is one material that results in the forming the base of unconfined aquifers, and also the top layer of confined aquifers, because it is an impermeable material through which water flow is uh, nearly not possible. Okay. Now, before we move on to the next question, I would like to discuss about this topic called storage coefficient or storativity. So, storage coefficient or storativity, we had learned about what specific yield of an aquifer is. So, specific yield of an aquifer is nothing but the amount of water, the volume of water that is released as a result of gravity per unit area, per unit hydraulic head, or per unit head. In the same way, when this quantity is measured for a confined aquifer, the uh, term that is equivalent to specific yield is called as storage coefficient or storativity. Now, storativity and storage coefficient is interchangeably used for confined as well as unconfined aquifer. But when it comes to unconfined aquifer, since the water movement is as a result of the gravity, we call it as specific yield. For confined aquifer, we call it as storage coefficient. Now, if you see here in this video,
For
this is an unconfined aquifer. So when an unconfined aquifer of unit cross-sectional area, that is by the width and the width and the length is going to be 1 meter square. And for such an aquifer, when 1 meter of pressure head of water is lost, then the corresponding volume that is lost as a result of that gives us the specific yield of the aquifer. Now, in case of confined aquifer, what happens is this confined water in confined aquifer is already going to be under some sort of pressure. So even if 1 meter of water goes down, what amount of water is obtained, but the level of this water is not going to reduce within this aquifer. That is because this aquifer, water in this aquifer is always having some extra pressure, hydrostatic pressure on it as a result of the confinement of the water within this. So this term is called as the storativity. Now we see that the storativity has got is a dimensionless unit, and here they show how why it is.
unconfined aquifer, let us visualize the definition. As you see,
You can see that values of storativity generally ranges from 0.005 to 0.0005, and we will also see here that the depiction is mu star, and why is it being a dimensionless unit. You see that although water is going and 1 meter loss is there, this water level in here is not going to reduce because it is already under pressure. So the pressure release is only happening. Now we said it is the volume of water per unit cross-sectional area per unit hydraulic head. So as a result of that, when these two cancel out, we get that the unit of storage coefficient is dimensionless. So the third question associated with this is, what is the unit or the dimension of the storage coefficient? You can put in your answers now, since we have explained about what storage coefficient, about its value, about its unit. So do give in your answers. Okay, so the correct answer is dimensionless, like how they had, you had seen in the video. It is volume of water that is released from the aquifer from a unit cross section from an aquifer with unit cross sectional area, and for a depth of, I mean, for a loss of water head of 1 meter, or unit pressure head is what is called as storage coefficient. So when you cancel out the units, ultimately the quantity is going to be a dimensionless quantity. So this storage coefficient of storativity is also a very important concept that is covered in this week's lecture. So we'll have a couple of questions associated with that also. Now, porosity, what does porosity refer to? We had learned about what porosity is, what is the ratio of what and um, what is the mathematical representation of porosity. Now, what does uh, the term porosity refer to? Does it refer to the shape of the particles? Does it refer to the sorting of the particles? Does it refer to the percentage of pore space in a material or percentage of cement in a material? Okay, so the correct answer is percentage of pore spaces. So we had studied that porosity is nothing but the ratio of the volume of the voids to the volume of the soil. We had learned about two quantities, porosity and void ratio. Porosity is the volume of the voids to the volume of the total soil, and void ratio is the volume of the voids to the volume of the solid particles that constitute the soil. So if you take the entire volume of soil, there will be solid particles also, there will be pore spaces also. This is what is encompassing the entirety of the soil volume. When the ratio of the volume of voids, when the volume of voids is compared to the volume of soil, it is called porosity. Void ratio is the ratio of the volume of voids to the volume of the solid particles that is comprising of the soil particles. So this is basically a percentage of the volume of voids in the soil material. So the correct answer would be option C, percentage of pore space in the material. Moving on to the next question. Porosity is independent on which of the following parameter? So porosity is a property of the void of the aquifer material, which takes into consideration the void spaces, the pore spaces in the material. So which parameter is it independent of? Is it dependent or independent of the particle's shape, packing, sorting, or hardness? Okay, so moving on. The correct option is answer D. Now, porosity is a property of the aquifer material or soil material or rock or whatever geological material, and it depends on the shape of the particles, the packing of the particles, and degree of sorting of the components of the particles. Now, what does this? We know what shape of a particles. It can be round. It can be angle edged. I mean, particles can be having sharp edges. So it depends on the shape of the particle. Now, what does the packing of the particle means? You see here, these are loosely packed materials. Loosely packed is when there are large particles and there are large pore spaces. This is also loosely packed. It is not very tightly fit with each other. Now, shape is again the rounded shapes. And if you, the sorting of the particle is nothing but, if say, suppose the smaller particles are on the top layer, then there is a layer of particles which are larger inside. So, how well or is graded or particles sorted out in a material is also representative. Porosity depends on that factor. So, the three important factors porosity of an object or of a soil material depends on is the shape of the particle, the packing of the particle, as well as the sorting of the particle. So here they're saying uniform and well sorted grains. That is, if it is uniformly sorted, initially there is a small size particle. After that, the size of the particle is gradually increasing. Then we say it is a uniformly sorted material. But heterogeneous sorting means randomly there'll be some portions which are having a small size particle, then there another portion with large size particle, and in between there'll be large and small size particle together. So that kind of very disorderly kind of sorting is giving rise to lesser porosity. So the sixth question, water is flowing through permeable materials faster than impermeable materials. Is the statement true or false? So the statement is true. Permeability is the ease with which water can flow through a medium. So permeable materials means there'll be easy flow of water. So it is definitely going to flow faster than how water flows in impermeable material. Moving on to the next question. A soil sample with a large amount of space between the particles will have a higher porosity, low permeability, high capillarity, or low infiltration. Okay, so we have been consistently discussing about what porosity is. Porosity is basically the volume of voids or the percentage of voids in a solid material. So larger the amount of pores, larger will be the porosity. So the correct answer is option A, high porosity. Moving on to the eighth question. If a rock is compressed and its volume is decreased, how will the rock's density and porosity be affected? Take your time, read, understand the question. What is you very well know what is the definition of density and what is the definition of porosity. So which option out of this four would be right? Okay, so let's just check what the answer is. So basically, density is nothing but mass by volume. So if the rock is compressed, it means that the volume is, they say that the volume is decreasing. So density is inversely proportional to the volume. So if the volume decreases, density will increase. So density is going to increase. And since porosity will decrease because when a material compresses, whatever pore spaces in it is going to be removed from there. So porosity will decrease. So the correct answer is density will increase and porosity will decrease. So again, since density is inversely proportional to volume, a decrease in the volume is going to increase the density. Now, regarding porosity, if a material is compressed, a lot of air spaces and pore spaces in that are going to be removed, because of which the volume is going to decrease. And due to this, the porosity is going to decrease while the density increases. Now, moving on to this question, the value of bulk modulus of compression for plastic clay lies in the range of which of the following ranges? This is something that has been taken during your lecture. So if you've gone through the lectures, you will be familiar with this answer. Okay, let's discuss this. The correct answer is C. Let's go to the portions that is talking about this bulk modulus of compression. So we talked about what storage coefficient is or storativity is. Now we had also seen that the value of storativity in most of the time in confined aquifers, it is lying between this range 0.0005 to 0.00005. 0.00005. Now as a thumb rule, we can also estimate, if we know the thickness of the aquifer, we can also estimate storage coefficient as 3 into 10 to the power minus 6 times the aquifer thickness. Now, storage coefficient is determined using tests like pumping tests and groundwater fluctuations. So, in confined aquifers, we know that confined aquifers are at a high pressure. It's not at the atmospheric pressure. It is at a pressure that is higher than the atmospheric pressure. So say if the pressure is really high, then there is a condition called the artesian condition where the water is going to start flowing out of the, if a tube well is drilled into a confined aquifer as a result of excess pressure, the water is going to flow out. Now, when we are installing a pump and when you take water from these aquifers, this will result in the reduction of the pressure in the water in the confined aquifer. And then after a point of time, the water is released not because of pressure, but is released from whatever water is there stored in that aquifer or because of the expansion of the water material itself. In such cases, they follow this equation where the storage coefficient is a function of the unit weight of water, the thickness of the aquifer, as well as the bulk modulus of elasticity of water and the property of bulk modulus of elasticity of the aquifer material. So here we are talking about the storativity being a function of the thickness of the aquifer alone. Whereas in here, what is happening is once the pressure of the water is reduced as a result of continuous pumping, the water that will be coming out from the storage of the aquifer or because of the expansion of the expansion of the water itself. From the storage of the material, the water bearing material or the aquifer material is going to get compressed, and as a result of it, water is going to be obtained as a result of that, or the water material is going to expand as a result of it, water is going to be obtained from the well. Under such conditions, storage coefficient is calculated as a function of the unit weight of water, the thickness of the water, the bulk modulus of elasticity of water, bulk modulus of elasticity of the aquifer material, and porosity. Now, alpha and beta is not equal to the bulk modulus. It is a reciprocal of the bulk modulus of elasticity. Beta is the reciprocal of the bulk modulus of elasticity of water, which we know is this value, whereas alpha is the reciprocal of the bulk modulus of the aquifer material. Now, depending on aquifer materials, the bulk modulus of elasticity is going to vary. So, there is a list of materials that has been provided in the lecture material. One is starting the plastic clay, stiff clay, medium to hard clay, loose sand, dense sandy gravel, rock fissure and jointed material, then rock, which is rock sound. I don't know what rock sound is, maybe very hard rocks. So corresponding to all of that, these are the bulk models of compression. So for plastic clay, it is 5 to 40, 40 to 80 is for stiff clay, and respectively, all the values are increasing as the uh, porosity. You can see that as the porosity increases, the bulk modulus of compression or elasticity is also increasing. So this is some values that you will have to learn by heart. There is no way around it. So this question was basically, what is the bulk modulus of compression for plastic clay? In what range it falls under? That is the first material that is provided in the table, and it is corresponding to 5 to 40 Newton per meter square. So all these are to show that where is this bulk modulus of compression and elasticity coming. This is coming the portion which is giving us methods to estimate the storage coefficient or storativity. Now the 10th question. This is a numerical. I expect both of you to do the question. Take your time, do the question. This in here, an aquifer is given, its thickness is given, hydraulic conductivity is given. It's a very simple numerical. You need to calculate the transmissivity, and the answer should be in meter square per day. So again, be careful of the units that are provided in the values for the problem, and what unit you want the answer in. So based on all of that, please do the problem and put in your answers in the chat box. Once the answers are there only, I will be discussing the solution. Has anyone got the answer? Let's move on to the solution. So this is a pretty direct problem. We know transmissivity is the product of the hydraulic conductivity and the thickness. Hydraulic conductivity is given as 2 into 10 to the power minus 6 meter per second, and thickness is given as 622. So first we'll multiply these two values. We get 1244 into 10 to the power minus 6 meter square per second. But here, since they have asked for the value in terms of meter square per day, we calculate the uh, value in terms per meter per day, meter square per day, by multiplying it with minutes, hours, and seconds, minutes, and hours in a day. And finally, we get 107.48 meter square per day as the correct answer, which is option C. So this is why it is important that you take into consideration the units. Although the values are given in terms of meter and meter per second, the answer that we require is in meter square per day. So it is necessary you do the required conversion to obtain the final answer. Okay, moving on. Which of the following will be the void ratio of a soil with porosity 22%? So for your reference, I have defined here what the we had learned about what void ratio and porosity is. Again, repeating, void ratio is the ratio of the volume of voids to the volume of the solid particle, whereas porosity is the ratio of the volume of voids to the volume of the entire soil. Now, how is porosity and void ratio related? It is mathematically related in the form in this way. E is equal to n by 1 minus n, where E is void ratio, n is porosity, or n is equal to E by 1 plus E. Now, in this problem, what is given is the porosity. You have to find the void ratio. Now, porosity, if it is given as 22%, you will have to use the value as 0.22. Using that 0.22 value, please find out the void ratio. It's a very simple question. You can directly substitute in the required formula and find out the answer. Again, please put in your answers, only after which I'll be discussing the solution. Okay, so let's move on to the solution. So as the formula here states, we have been given the quantity of porosity, which is 0.22. Porosity void ratio is linked to porosity using this formula n by 1 minus n. So if you substitute the value 0.22 into 1 divided by 1 minus 0.22, we get the value as 0.28, which is option C. So many questions of this format can come where void ratio will be given, you will have to find the porosity, or porosity is given, find the void ratio. This relation is very important. It's important that you know this relation. E is equal to n by 1 minus n and n is equal to E by 1 plus E. Also clearly have an idea about what E is equal to, volume of voids by volume of the solid particles. Porosity is volume of voids to volume of the entire soil. Now again, this next question is talking about another parameter or quantification called degree of saturation. So a degree of saturation of a soil is nothing but it is the volume of the water to the volume of voids. Now, if you're considering a total volume of pores in a soil material, how much of the pores is consisting of water to the total volume of pores is referred to as a degree of saturation. So, how much of the pores are filled with water is what is being given by this quantity. So the degree of saturation is given by the volume of water in the pores to the total volume of pores or voids. Now, what is the degree of saturation going to be for a fully saturated soil sample? So, fully saturated means if all the volume of all the pores are filled with water, what is going to be the degree of saturation? So, correct answer is option D. So when all the volume of if V is the volume of pores, if all the pores are filled with water, this volume of pores is going to be equal to the volume of water, and it is going to be cancelling out, and it's going to be 1. So the degree of saturation for a fully saturated soil sample is 1, and the correct answer is option D. Now, corresponding to this itself, another question in a different way. What is the degree of saturation of a very dry sample equal to 0? Is the statement true or false? Okay. So the correct answer is option A, true. We just now learned that if the sample is fully saturated, the degree of saturation is going to be 1. So if it is not at all saturated, that entirety of pores have 0 amount of water, the volume of water is going to be 0, which means the degree of saturation is going to be 0. So the correct answer is option A, that is degree of saturation for a very dry sample is going to be 0. Again, a repetition of the question, but here you have to recognize the formula. Which of the following is giving the relationship between porosity and void ratio? Which answer out of this is right? Let's see the answer. So we know the relation between porosity and void ratio in this format will be n is equal to E by 1 plus E. But here none of the options are E by 1 plus E. We have option D which is 1 by 1 plus E. And again option A and B that has got 1 plus N and 1 minus N. So let's take the option B in that if 1 minus N is equal to 1 by 1 plus E, that means if you bring the RHS to the LHS, it becomes 1 minus 1 by 1 plus E is equal to N. Again, if you rearrange the terms, it is going to be E by 1 plus E, which is equal to N. So correct answer would be option B. 1 minus N is equal to 1 by 1 plus E. This is also very simple, which can help you score marks if you are a little bit careful with observing the options. Next question, again, a relation between porosity and void ratio. Void ratio is given, find the porosity. You know the relation, how porosity and void ratio are related to each other. So please go ahead and find the answer and share it here. Only after which I'll be discussing the answer. Okay, moving on to the discussion of the answer. We know N is equal to E by 1 plus E. So direct substitution 0.35 by 1.35, which is equal to 0.259. And when you convert it to percentage, it will be 25.9 percentage, which is option C. So this is how you do such problems. Moving on to 16th question. What is the fraction of total porosity available for fluid flow called as? Is it called the kinematic porosity, effective porosity, degree of saturation, or both A and B? Okay, so let's discuss about the concept of effective porosity. So correct answer is D, both A and B. So effective porosity, or another word used for effective porosity, is also called kinematic porosity. So when you take an entire porous medium, some portion of it, there might not be water flow. Some portion of it there will be water flow. So that portion of the porous material through which water or gas or any fluid flow is happening is what is called the effective porosity. So effective porosity will be the ratio of the volume of water that is able to pass through the porous medium to the total volume of the porous medium. So another term for effective porosity is kinematic porosity. So the answer for this would be both A and B, which is option D. Now, what is the other name for hydraulic conductivity? Again, a concept that we had discussed in earlier classes. Is it hydraulic gradient, coefficient of permeability, degree of saturation, or none of these terms is corresponding to hydraulic conductivity? So the correct option is option B. We had discussed in many classes, hydraulic conductivity is nothing but coefficient of permeability, and unit of it is in terms of units of velocity, meter per second or centimeter per second. Hydraulic gradient is the change in the pressure head uh, to the length of flow where this pressure flow where the pressure head change is happening. That is a dimensionless quantity. Degree of saturation we discussed earlier is the volume of water to the volume of the voids. So in here the correct option is option B. Now next question. Permeability is affected by which all factors out of this? Permeability is affected by all of the following factors except for one. Which factor is that? We did check, we did talk about what all factors porosity depends upon. So here, what all factors does permeability depend upon? Okay, so the correct answer for this is option D. We learned about porosity. Permeability is also affected by the grain size distribution, the texture of the soil, as well as the structure of the soil. The only factor that it does not depend upon is specific gravity of water. Again, I'm a bit doubtful about this question. So I'm not sure if this is the correct answer or this question has been framed properly. So let me just look into this question once more, because in we permeability is also a factor of this gravity of what specific gravity of water. So I don't know how this option would be right. So let me just check into this question, and then I will modify it accordingly in the slides that I upload. So let this I'm not guaranteeing that this is the correct answer over here, although that is what is given. We'll move to the next question. Which of the following rock formations has the highest porosity? Okay, so we know that sandstone is a sedimentary rock that has got a lot of pore spaces. Again, limestone is also one of sedimentary rock, but it is not as porous as sandstone. Granite is igneous rock. Marble is metamorphic rock. Granite is zero pores. Marble also doesn't have pore spaces in it. They're very highly consolidated rocks. So the correct answer is option A. Now, what does permeability refer to out of these four options? Is it the volume of water released from groundwater storage per unit surface area of aquifer? Is it the density of the total soil or rock material, solids and voids after drying? Is it the ability of a rock or soil to transmit water through its void spaces? Or is it the measure of the void spaces that is filled by recoverable oil or gas? So the correct answer is option C. It is the ability of a rock or soil to transmit water. We have over and again discussed that permeability is the ease with which a material can help in transmitting water through it. Now, the first option is something related to the storativity of specific yield, volume of water released from groundwater storage per unit surface area per unit hydraulic gradient is called as specific yield or storativity or storage coefficient. In this case, we are talking about permeability, which is the ease with which water flows through material. And so, the ability of a rock or soil to transmit water through its void spaces is what is the right answer. And probably we'll take a 5 minutes break. Not 5 minutes, it's the time is 7:03 now. We can be back by 7:06, 3 minutes. So yes, let's move on to the next question. Intrinsic or specific permeability is represented with which of the following equations? Okay, I've already given the answer. So this is a new concept that probably we haven't discussed. So it is option A, CD square. Let's see what intrinsic permeability or specific permeability is. So intrinsic or specific permeability is given by this equation, small k. So till now we talked about coefficient of permeability or hydraulic conductivity, which is depicted by capital K. Small k is equal to C into D square, where C is a constant that is summarizing the properties of the medium through which water is flowing. And it has got the dimension of L square. That L square means it is either centimeter square, or meter square, or whatever. And D is the effective size of the material. Now, since K is expressed usually K is expressed in centimeter squares, the unit is going to be very small. So as a result of it, there's another unit called Darcy, which is a representative of 0.987 into 10 to the power 8, 10 to the power minus 8 centimeter square is equal to 1 Darcy. Now, how is this coefficient of permeability and intrinsic permeability related? Coefficient of permeability K is a product of the intrinsic permeability and the unit weight of water by dynamic viscosity. So dynamic viscosity is a property of a fluid which is resisting its flow when there's some external force like friction or something is exerted on the fluid. Then a resistance offered by the fluid is basically what viscosity is. Now dynamic viscosity of what is a function of temperature. So the unit weight of water at 20 degrees Celsius is equal to 9,800 and something Newton per meter cube. Dynamic viscosity is equal to again 8.9 into 10 to the power minus 3 or minus 4 uh, Newton per meter square, and no, sorry, Newton second per meter square. So when the units I mean when the values are substituted in this equation, we will get that 1 Darcy of coefficient of permeability is equal to 0.966 into 10 to the power minus 3 centimeter per second for water at 20 degrees Celsius. So we see here that coefficient of permeability is not just a property of the material, but it is also representative of the properties of water that is flowing through it. Since it is water that we are considering, it is representative of the properties of water that is flowing through it. Whereas intrinsic permeability is only representative of the material. What is the geometrical properties of the material? What is the effective size of the material? So this in the earlier question that I had said, where the permeability is affected by all of the following factors except for this one, I think it is the intrinsic permeability is affected by all of the factors except specific gravity. Intrinsic permeability depends on grain size, that is effective size means the grain size, soil texture and the soil structure, but not on the properties of the fluid that is flowing through it. Whereas coefficient of permeability is a function of the water also that is flowing through it. So that is the difference between intrinsic permeability and coefficient of permeability. Intrinsic permeability is also called as the specific permeability. Its unit is in centimeter square, whereas coefficient of permeability unit is in centimeter per second. So this is an important concept, and it is here again characterizing the property of the material alone, whereas hydraulic conductivity or coefficient of permeability is considering not only the property of the medium but also the property of fluid that is flowing through that medium. So intrinsic permeability, option A is the correct answer, C into D square. C is a constant that describes the geometrical properties of the material. D is the effective size of the material. Next question, a soil sample with a less amount of space between the particles will have what? Low porosity, high permeability, high capillarity, or low infiltration rate? So the correct answer is option A, low porosity. More number of pores, more porosity, less amount of pores, which is basically space, less porosity. So the correct answer is option A. Again, a problem that is asking you to calculate the transmissivity in meter square per day. Here the thickness is given, hydraulic conductivity is given. Find the transmissivity in meter square per day. Something similar to an earlier problem that we had done. Please do this also. So So again, this is a repetition of an earlier problem that we had discussed. The thickness is given, hydraulic conductivity is given. Product of the thickness and hydraulic conductivity we'll find out, which is obtained in meter square per second. So the transmissivity asked is in meter square per day. So then we have to convert it as required by multiplying it with 24 into 3600. And then you will obtain the answer as option A. Again, a problem on, okay, this is a more challenging problem. A soil sample has a volume of voids. The volume of voids is given and the total volume of the soil is given. Volume of voids is 50. Volume of soil, total volume is 200 centimeter cube. What is the porosity is the question. So you have to be, yeah, if you know the definition of porosity, it is a very simple thing to be done. Okay, so the correct answer is 25%. Simple, 50 divided by 200 into the percentage, which is 0.25 into 100, gives us 25%. Next question. If an unconfined aquifer has a specific retention of 0.15, and if the porosity of the aquifer is 0.35, what will be the specific yield? So you know about the relation between specific retention, specific yield, and porosity. So using that relation, you can find out this answer very easily. Simple matter of addition and subtraction. Hanumanta, you joined a bit late, but again, you can put in your answers if you know the relation. Okay, let's move to the answer. So we know the relation between specific retention and specific yield and porosity. Sum of the specific yield and specific retention is equal to porosity. So here porosity is given, specific retention is given. We need to find the specific yield. So 0.35 minus 0.15, 0.2 will be the specific yield. So the correct answer will be option B. This will be the last question for the day. What is the dimension of transmissivity? So you know what the transmissivity's definition is. You don't have to calculate anything. You just have to say what is the dimension of it. You know the unit. So from the unit, you can find out the dimension. So the correct answer is option B. So we know the unit of transmittivity as meter square per second. So dimension for length is L, mass is M, time is t. Since there's no unit of mass over here, mass will be to the power 0. There's a power of 2 to the unit of length, so L to the power 2, and power of minus 1 to the unit of time, since it's in the denominator, so it will be t to the power minus 1. So it will be m to the power 0, L to the power 2, t to the power minus 1. Correct answer will be option B. So that's the end of the questions here. If you have any doubts or want to discuss any more of the questions that have been shown in the slides here today, I'll be here. If you don't have any doubts, you're free to leave the session. Yes, Anumanta. Thank you, Chakravarti. Do you mean the assignment 4? Because of the mathematical part. Um, maybe that's because I'll be discussing those assignment questions. So even if it is a bit difficult during the for the assignments, it's pretty repetitive questions. When whatever you do in your assignment, whatever we discuss in the problem solving sessions are what that comes for the exams. So if there's any particular part you want me to explain again, I can do it in the next session with some extra problems. If you attend that session, we will practice more of that question. So if you can mention which exactly is the portions that you found difficult, we'll do more problems of that. Eventually, when you practice a lot, it'll become easy. Yes, all the PPTs that I take for all the sessions are being shared in that Google Drive. The link is there, and if you open the portal you will have the link to it for all of the problem solving session, and the videos link also will be there, so you can go through the slides. And if there's any particular portion that you want to discuss again, like this mathematical problems, a couple of them were there in this today's session. There were a lot of problems regarding porosity, void, ratio, transmissivity. It's only when you do a lot of it that the concept becomes clear and it'll be easier for you. So it's good if you attend the problem solving sessions and sit and do during the session. Then you won't need extra practice. If there's any portion you particularly want me to take, please do. Okay. Which question? Is it the permeability one?
For unconfined equivalent is
Thank you, Hanumanta. If there isn't any doubt, you're free to leave the session. Arif, do you have any doubts? Okay, then you can leave the session.